Good evening. How's the volume? Good? Too loud? Too quiet? Can you hear me? Okay. Okay. Excellent. My name is Angela Metler. I am an administrative assistant in the president's office at the South Dakota School of Mines and Technology. Welcome to STEAM Cafe. Thank you for attending. We also have people attending online as well. So thank you to those of you who are attending virtually. At the end, there will be a Q&A session. If you're attending virtually, you can type your question in either the chat or the Q&A box, and I will make sure your question gets answered live at the end of the presentation. Those of you who are sitting here can pretend like you're back in college and raise your hand. STEAM Cafe is a partnership with Hay Camp and South Dakota Public Broadcasting. We've been putting STEAM Cafe on since April of 2018. We couldn't do it without you, so thank you for continuing to attend every third Tuesday. I'm not going to take up a lot of time. I will turn it over to tonight's presenters, Dr. Michael West and Dr. Katrina Donovan.
All right. Anyway, thank you so much for coming. Really glad to be here. I'm Michael West. I'm the head of Materials and Metallurgical Engineering, and
I'm Dr. Katrina Donovan, a lecturer in the Materials and Metallurgical Engineering Department.
excellent. And we're really excited to tell you about a new initiative at the school. And I'm going to tell you a little bit about some of the history about this initiative, how it came about, and what we have planned, and maybe some preliminary results and some preliminary things that we've been doing. So without further ado, we'll start here. So just a little bit about the program that we're in. So we're in the Department of Materials and Metallurgical Engineering. We have one of the few metallurgical engineering undergraduate programs in the US. And so it's a unique program for sure. You can kind of see here the kind of a flow chart of what we do, but really we take over where mining leaves off and we process those materials to extract the metal to actually produce the materials and metals that we make everything out of. So it could be making steel, or it could be making aluminum alloys that are pictured there. Then we process those materials so that they have the properties we need, and ultimately we're the ones that measure those properties, make sure they can perform, and but we're also the ones that are involved heavily in recycling too, so it kind of feeds back into the front end. As an example, one of our strong industry partners at the university is Nucor Steel. They're North America's biggest steel maker. They're also North America's biggest recycler. So all the steel they produce is recycled material. So that obviously is playing a more and more important role in what we do with materials, with just critical materials and critical minerals. So that's a little bit our program, and we're actually going to watch a video here, and we'll start this. I kind of want to start off with this video as kind of a history of where we've been and where we're going. So we'll see if this works here.
The South Dakota Mines team set out to make our own version of an 1860s cavalry saber using 1095 steel, which is the modern equivalent. Historical research found that some period swords were tempered in unique ways using molten lead. This inspired our team to do an isothermal ostempering process to get a bainite microstructure. The isothermal treatment was accomplished by quenching the sword in molten lead 340 degrees Celsius and holding for 1 hour. Proper PPE and safety standards were maintained during the making of this video. All forging was done by hand at approximately 1200 degrees Celsius. The time in the forge was minimized to reduce decarburization when possible. We started with a straight blade, then pre-bent to the opposite side of the cutting edge. During the beveling process, the blade naturally savored the correct direction due to steel expansion. In order to maintain safety while working with molten lead, we held a fan blowing fumes out of the garage, as well as wearing masks and eye protection. Straight from austenitizing, the blade was quenched in a molten lead bath and held for an hour. The temperature was maintained with a pyrometer and frequent agitation. A wax mold with sprues and vents was dipped in a suspended ceramic slurry to create a cast form. This was fired to completely harden the mold before casting. We wanted to create our own garden pommel by investment casting brass, inspired by historical designs. The handle was wrapped in white rayskin and brass thread. The team recreated historical floral scroll patterning above the ricasso using an acrylic paint and an improvised electro-etching technique. The handle of the sword was secured by peening the tang. A blade balance calculator program was used to measure the effectiveness of the blade design to make sure optimal balance.
Well, I just wanted to watch that again, I think. It's so cool. Really, what you saw there is a culmination of something that we've been doing for several years at the School of Mines. And so let me tell you a little bit about that. So several years ago, we integrated blacksmithing into our metallurgical curriculum. And the idea was to use sort of hands-on learning to enhance student learning of fundamentals of metals. And we really had success with students getting a better understanding of metalworking concepts. One of the things that happened as part of this was that these activities that we were doing actually led to an international student competition. You saw there the video that the students made for this competition for this year. They're actually going to go to California in 2 weeks and compete with about 20 other teams from all over the world. It's kind of like Forged in Fire, okay, if you've seen that, but it's more about the science behind making this blade, although the blade and the creativity is also judged. And we actually started this competition before Forged in Fire, so we didn't, steal their idea or anything like that. But it was really interesting outcome of what we had been doing. And it also led to a collaboration with a lot of different artists. Probably the main one being Mr. Jack Parks from Piedmont, South Dakota. So he's a master blacksmith who lives in the area here. But based on a lot of these activities, the students really actually, they started doing these forging activities, but they also started taking off and doing a lot of other artistic activities related to metals and materials. And so we had this idea about, well, can we really, instead of focusing on the hands-on learning, can we focus on this idea of integrating art, like the STEAM concept? Maybe some of you have heard the STEAM or the STEAM Cafe, but the idea was really to integrate art into STEM, into our curriculum, our metallurgical engineering curriculum. So that was kind of our idea. And so, the goals being, can we have more creative students, more innovative students? Can we learn things about entrepreneurship and creating products and things like that that may be artistic? And increase teamwork and collegiality, esprit de corps in our program, and in the end, increase the quality of our graduates. I mean, that was our interest, and make our graduates more desirable for industry partners and more well-rounded. So we pitched this idea to the National Science Foundation. They have a program, it's called Improved Undergraduate STEM Education Grant. And we pitched this idea, and the idea was to modify our labs with co-curricular activities related to glass materials. So glass blowing, ceramic materials. We also, through this program, proposed that we're going to add new curricular components, so new classes in ceramic materials. Those classes will actually cross-cut a lot of programs on our campus, like geological engineering, and they deal a lot with minerals, chemical engineering, and other programs. And also incorporate, art. So we're calling this effort Art and Engineering, but incorporate art into our engineering design projects, make our students more creative. Some other elements of this program are that we established a residence in art, artist in residence program, and that our artist in residence is actually Professor Emerita from the School of Mines, Deborah Mitchell, who's here today. She's one of our important team members. And also, we have teamed with our current art faculty, and Matthew Whitehead, who's in the back there, has been an important collaborator. But also the idea was to partner more with local artists. And one of the key people that we partnered with there is Tony Gerlach, who owns and operates a glass blowing studio called Mind Blown Studio. It's at the Pump House in Deadwood, South Dakota. It's like a historic pump house. It's really an amazing place. You can stop by and have coffee and watch her do glass blowing there. But a lot of what we're going to talk about, she has helped us with, and really want to acknowledge her help in establishing a glass blowing lab on campus. So that glass blowing lab is actually under construction right now on campus. And she provided the anchor gift for the glass furnace and some of the big pieces of equipment that we needed to get started with that effort. So she's been really integral to this effort. And the other element of this program is establishing a student organization, a STEAM student organization, STEAM club on campus. Dr. Donovan is going to talk a little bit more about that, but she's led the effort there to establish that STEAM student organization. So, what we're going to do now is talk about some of the things that we've started to do. So this program just kicked off last semester, and so we've gone about one semester, and so we're going to talk to you about some of the elements, especially some of the co-curricular elements and examples that we're integrating into our program right now. The first one, obviously we've done a lot of metalworking associated with the blacksmithing, but as part of our mechanical metallurgy class, students have to design and fabricate a functional tool through metalworking by hand. And so the idea, some of the principles that they learn there, you can see, how to visualize what are they going to make. Concepts of metalworking that involve temperature, color, also the mechanical properties. But in the end, we also want to make them, we want them to make something that has some intrinsic creativity and art to it. So that's one example that we're integrating into our curriculum in our mechanical metallurgy lab. In our physical metallurgy lab, we've done metal casting, and we've actually worked with some local artists like Grant Standard and James Van Nuys and others on projects that involve, for instance here, lost wax casting, where students again learn about visualization, sculpting. They learn principles about phase diagram and solidification of metals and things like that. So I'm going to turn it over to Dr. Donovan to talk about some of the activities that she's integrating.
So a lot of my activities focus on our introductory metallurgical engineering class. So it's the first year students who came in that are coming into our program. So this first one, we actually worked with Professor Whitehead on drawing one, and drawing has a very useful place within our curriculum, because when we think about things, we've talked about visualization, but we see a lot of things in 3D. If you look on the right-hand side, we see a simple cubic structure for a metal. Really teaching the students what these crystals look like in 3 dimensions is important. So on the bottom left-hand side, you can see 2 different students' artwork, and they were at this point just focusing on cubes because we deal with a lot of cubes in terms of crystal structure. The end of the assignment for that was pretty open-ended. It was submit your artwork, and we got quite a few cubes, but in the upper right-hand side, we let one of our students, we left it open-ended, and it's cool to see the creativity that came out of that. She drew a tractor, so that was her sketch. So Matthew's clearly a very good teacher. But some of the things we learned from this, obviously visualization, drawing, and this actually leads into our next one, which is CAD to 3D printing. So with CAD, I had a colleague of mine, he came in, we'd worked together, and he taught the 3D printing. And it was funny because we went straight from Matthew with an art background to somebody with a very technical background. And he says, where's your sketch pads? We need to draw what we're gonna 3D print. And so it was really cool to see somebody from the technical side also demanding that creativity and that initial idea. So when we think of CAD, we kind of want to think of what are we going to think about? So we start with an idea or a sketch. From there, we go into a computer program, and then we are sketching that out in 3D. From there, it's a slicing process. So if you can think about a book, that's kind of how the program reads it. There's a layer, kind of like a book. There's a page, there's a layer. And then lastly, you have a printed object. So some of the technical things that come from this, we have technical drafting with the CAD aspect, the design process, which is really interesting. If anybody's 3D printed or made something, sometimes you have to go back and think about it. And that's the purple bottom we see. If we've got a printed object and part of it didn't print right, we need to go back and look at the slicing, see if there's an issue there, or maybe all the way back to the drawing. Or maybe you have a customer like me who's like, yeah, I don't want a boat. I would rather have a kayak. So then you're all the way back at step one with a kayak. Actually, I would ask for a yacht, not a kayak. So with this design process on the bottom, I applied it to our first year students. And one of the students, his dorm room, we got part of the bed there, his phone kept falling off. So his idea was to print a phone holder so he could wake up and not drop his phone on the floor. He was successful. So this co-curricular activity, we just recently introduced it into Met 231. It's our precious metal clay, and Professor Mitchell, she was very, very helpful for me because I had never worked with metal clay, so it was a learning opportunity for me. Metal clay, as she described it, it acts like clay, but not like clay at all, which sounds very challenging, and it was. A lot of people had a lot of fun with it though. So what we learned from this is sculpting. And we also learned sintering. So if you look in the upper right-hand side, if you see a bunch of little circles, that's what the powder or the clay particles look like prior to sintering. When we sinter something, we heat it up really, really hot, and then we have a single solid object. So the little black spots you see, those are the void spaces, and then the solid white is the actual metal particle. The other thing we see with these two, this was done by a student. On the left-hand side is what the clay looks like before firing. Then on the right-hand side, it's after firing. So some of the things we see here with sintering too, we see a little bit of shrinkage. And then here's just some more images of the students' work. So we learned quite a bit from that one. It was pretty fun. Another co-curricular activity that Professor Matthew Whitehead helped with was, this one was actually done for an REU, and it's stained glass. So with stained glass, there's a couple different components we really need to think about. One of them being color theory. We can see a lot of different colors depending on how the color is integrated into the glass is pretty important. You can either integrate it or it can actually be painted on in some glass, stained glass cases. Glass properties, glass, if you cool it too fast, it can actually shatter. You've probably seen all the videos of somebody pulling glass bakingware out of the oven and rinsing it with water and it shatters. It can't handle a lot of that thermal shock. So that's something we need to think about from both an artistic and technical perspective. Soldering and flexing, that's how we connect the metal components to the glass components. So that materials integration at those interfaces there as well. And this one was a really new one. We just offered this fall in our Met 110 class. Jenna Saylor was great. She helped lead this project. Here's two different pieces she has done. And then this and this, those two images are from the class where the students are actually, the first year students are actually doing torch work themselves. So some of the things we get from this is visualization, just visualizing what these look like. Once again, thermal stress is what happens when we're integrating two different materials. In this case, we have glass and we have a colored glass we're integrating, but sometimes we have to be careful with that integration in terms of the thermal stresses and cooling too much. And just an overall glass structure and property. So we can see a lot of awesome artistic projects that came from this. One of the cool things that came out of this as well is this last summer, this is a technical piece of equipment I had. It's a glass piece. It runs about $250 to $300. And this upper part had snapped. And it wasn't critical to the readings and stuff, but what it did is it had a hole, so there wasn't a seal. And everyone's like, just put some super glue in there. The problem is the chemicals I'm running through there will eat through the super glue. The only way to fix this is to use glass. I called the company and they're like, yeah, just throw it away and buy a new one. So I reached out to Jenna, and Jenna, who taught this pendant making class, I'm like, hey, I just need this sealed. So she saved me in $16 in materials, a $300 bill. So it's very translational what we're learning in the class with these artistic components, how they can help in everyday life and in our lab settings. So this one, it was a really fun one. The students enjoyed that as well. Our current one that we're involved with this term is clay mineral processing. So this one's really fun. The Dr. Keller, who's the PI on this, he had spearheaded this idea with buckets of clay from around the Black Hills. And the students have to figure out how to process this. So mineral processing, they have to figure out particle size, and then they also have to figure out a chemical formulation to be able to make a ceramic body, or in this case, a pottery. So this one's the first fire that we'd see from a clay body, or sorry, this is prior to firing. This is the first firing, which is a bisque fire. And then he had put a glaze on and did a second firing. In the upper right-hand side, we actually have a picture of Professor Mitchell here, and then two of the students from this class. And one of the creative components of this is the students got to see two different ways to actually work with clay. Not clay they made, but already made clay. So it was a pretty unique opportunity for them as well to feel what their end product should feel like once they've completed this process. This activity was from the STEAM Club. So we did get our organization formed. Jenna, as I mentioned, she's the current president of that, but this was a really fun activity. If you guys look, you can see some cool structures and hopefully the color comes through. But this one was done by the STEAM Club, and they had heated bismuth up. It melts at about 270 degrees Celsius. So in Fahrenheit, that's about 540. They heated up and they were able to pour it in to a small disc. I actually have it at the back. If you guys want to see it, there's a table. Some of the cool things that come from this is you actually get to see these crystals grow. You can get crystal growth kinetics from that. The shiny color comes from the oxide layer. So when this cools, it's usually like a white pinkish hue, but when it cools, it gets all this iridescent color from like a yellow to a blue. So a lot of learning from that. There was a lot of cool stuff to see from that as well.
Excellent. So I think we're going to kind of team up on the last part of this, but one of the things that we're involved with now is how to assess some of these different things that we, if you refer back to some of the goals of increasing students' creativity and things like that, increasing student retention. So you can see here some of the assessment that we've started for the program. The first thing that we've been looking at is student self-efficacy. So that is, confidence in the technical environment. It's related to do they feel confident when they're doing these technical activities? And you can see here, this is some data that we gathered from the MET 110 class, I believe, where students talked about their, and you might have to help me with this.
I'm happy to. So with this one, if you look, there's creativity pre and post. It comes through kind of red for the pre and then gray for the post. The big thing to note with this one is when we pulled the students at the beginning of the term, we asked, we had a statement that said, I think of myself as a creative person, and they got to select not at all true to exactly true. The big thing to note is the shift we saw from some of these students, after completing the class, they did feel like a more creative individual, and that's their reflection on themselves. The other thing too is we are clearly interested in the creative part. We also have a technical program we're trying to deliver on, which is a metallurgical program, right? So we assessed that as well. Many of the students came in, and the question for this was, I think of myself as very knowledgeable about metallurgical engineering. And so if we look here for the pre, we see quite a few. a few that were nervous. The big thing to note is after completing the program or the course, excuse me, no one had felt that they were not knowledgeable in metallurgical engineering. So that was a good push for us. The other thing too is we didn't see anyone at exactly true. So there's still some learning to be done for this first year group, which is good for me.
One of the other things that we're also looking at is this idea of looking at student typology. And what we mean by that here, there is an instrument called the Herman Brain Dominance Inventory, and that's shown here. And basically what that can do is kind of quantify whether a student sort of falls into maybe what we think is the traditional engineer over here, very analytical typology versus, you can see here experimental, practical, relational. We have data at the school, and one of the people that is helping us with this assessment, Dr. Stuart Kellogg, has a lot of data at the school that says when engineers come into the school, if you map their typology, they are all over the map. But when they end, most of them are over here. And what his data shows, because your typology doesn't really change, what that shows is we lose those students. We tend to teach more towards this, side in engineering. And so what we're trying to do is give, outlets and integrate things that may appeal to students that have maybe a different typology. And so that's really exciting. We have anecdotal evidence that some students have persisted in our program because they have an outlet like bladesmithing or things like that. And so, so what we're really trying to do is quantify, are we getting students of different typology? They make good engineers, and they're very valued because they may have other skills that, normal graduating engineers won't have. We haven't started these yet, but there are other instruments that can be used. And I know that there's some other people from on campus here that use some of these instruments to look at, are we improving creativity and innovation? Are we improving critical thinking by integrating some of these things into our curriculum? So, so that's going to be exciting to see what some of those instruments tell us.
So what we have here, some of the things we were planning to propose and establish a student art and engineering competition on campus, similar to what happened with the bladesmithing. One of the cool things that was just on campus December through beginning of February was what's called the 150 millimeter challenge. So artists started with just a small 150 millimeter piece, but the cool thing is there's a whole bunch of art that came from that. And so that's one of the challenges that was presented. We have the student art show. So just supporting a lot of these. Currently we're reaching out with the American Ceramics Society because glass and some of the ceramics fit in really well with them, to see about a national competition. There is a current competition in our junior design class as well. So results to be determined at this point, but that's the current. One more figure I did want to show you was kind of related back to what we saw on the previous slide, but it relates to the students in their self-efficacy, or that confidence they have in themselves. So when we start throwing torches in molten metal, that can be a little bit intimidating when you're a first year coming in and seeing this in a setting. So one of the group components we had was grouping the students, and they got to do this. If we look at the for the metal casting, they were given a prompt that said eye casting. There was not a large number of students that would be stressed by this. Some of our students come in with quite a bit of metal experience, And then there was some that were very excited. The thing to note though is at the end of it, we did see a shift towards if at the end of the term they were asked to cast something, they would be more excited about it versus stressed about it. That was a good baseline. With introducing the glass into it, we wanted to kind of probe and see what that looked like. So for creating a pendant, prior to doing it, we saw about 9 students that would feel some level of anxiety in being asked to create something like a pendant. The interesting thing is after completing the lab, we saw only 1 student that would feel some level of stress with being asked to do that. That same student also said they would feel some level of stress with metal casting. So introducing these things, not only does it build that creativity, it's also building confidence within our students.
One of the other things that we're, in terms of extended outcomes that we're hoping from this program is to really partner more with the broader arts community. We've been in discussions with the Rapid City Art Council, for instance, to collaborate. We're hoping to expand that collaboration to K through 12 students and teachers that may be, in art classes or art teachers, but may be also interested in STEM. You can see some of the different, outreach activities that we've done recently. Here we're working with Boy Scouts doing the metalworking merit badge. That actually will come up here again in another month. You can see here Dr. Donovan 3D printing with a big group of Girl Scouts. And here in the middle, actually, we've partnered with the Newman Center at the School of Mines to actually design. So students are going to design. They're working with with Matthew Whitehead, and but they're going to work on designing and implementing stained glass windows into the Newman Center. And then, Kat, would you like to talk a little bit about this?
Yeah, so in the upper right-hand side, we being Professor Mitchell and I, Jenna's also in there as well. We went to the South Dakota High School STEM Education Conference to talk with STEM educators about just the different curriculum we have going on here, but we did a kinesthetic hands-on learning lab with them where they got to do the metal clay themselves. So that's all of them working on their metal clay samples. So it was a really, really enjoyable trip, and the high school teachers seemed to really enjoy that activity.
We also, we've traditionally had a number of summer programs that we've done related to materials, but we really want to expand this idea of integrating art into some of these different camps, and we've already started doing this. We've got an upcoming materials camp. This involves learning principles of metallurgy and materials, but we're really going to integrate this summer a lot of these artistic components that we've talked about. We've started a new camp called the Science of Swords camp. It's like a forged in fire camp for students. We've piloted a junior, that's like a high school and middle school bladesmithing competition. We piloted that last year. One of the winning entries here was from a high school student from Sioux Falls area here. Made this incredible knife that won this junior competition that we rolled out. But he is a very creative student. Kat has worked a lot with high school students, especially in 3D printing. It involves, a lot of these visualization and sort of modeling to CAD to printing projects. And then maybe I'll let you take this last bullet because I know you're really doing a lot of work in that area.
Yeah, so the image here in the middle is of 2 high school teachers that attended last year a high school teacher/student workshop. And it was focused on 3D printing. So they came, built their 3D printers, and then they got to go back to their home institutions, and I helped them create modules for that. We'll also be doing that again this summer.
This, before we leave this slide, I thought I'd mention this student was also on the bladesmithing video, but this student here, Tyler Reinartz, was recently actually competed on Forged in Fire, which was really pretty cool for us. I think we can publicly say that now. It was kind of secret for a while. He couldn't talk about it until the episode aired, but it was really interesting, and he did very well. It was very cool to watch him on that competition. So we're gonna wrap up here, I think, with sort of one last video. It's very short here, but it's kind of describes where we are and where we want to go with this program. So I'm gonna play this.
At South Dakota Mines, we use the science of metal and glass to empower works of art. Students work with both professional artists and STEM professors to infuse their creations with metallurgical and materials engineering. Our projects are inspired by our industry partners to bring you to the cutting edge of science, engineering, and art. Come change the world with us. Check out this one-of-a-kind art and engineering program offered only at South Dakota Mines.
That's another very cool video, and have to acknowledge our marketing and communications for helping us with that video, but because I think they really captured what we're trying to do, captured that student enthusiasm, and so really want to acknowledge them, and really also want to acknowledge public broadcasting as well, South Dakota Public Broadcasting, because they've been there all along to sort of help us and help get the word out about some of the cool things we've been doing in the program. Just some acknowledgements here, but really want to acknowledge some of our team members on this NSF award here. Some are here today, like Matthew Whitehead, but really want to acknowledge John Keller, who's the PI on this this grant, and also Cassandra Burincott from Mechanical Engineering. Again, Deb Mitchell, who's our resident, artist in residence. Dr. Stuart Kellogg, who's a retired faculty in industrial engineering. You can see here the STEAM Club members and some of the student artwork that you saw. The bladesmithing team members who are going to compete here in a couple weeks. And also really, again, wanted to thank so many artists. These are just a few that we have worked with. We hope to work with more. And so if, we'd be happy if any of you have any one to refer to us, we'd be happy to partner with them on some interesting ideas to infuse art in our program. And again, really want to acknowledge the university marketing and communications team, especially Mike Ray, who I see there in the back. Thank you so much, Mike. And so that is our last slide. Thank you very much. Be happy to answer any questions.
Additionally, I did just want to let you guys know, if you want to use your phone, there's a QR code for our website for the art and engineering program. So it's under construction, but there's some things to see.
And in the back, there are some examples of some student work back there that we brought, but there's also just some flyers on the program. There's some cool stickers. I know we passed around a few stickers, but there's some cool art and engineering stickers. So just invite you to, if you hang around for a little bit, to check out some of the cool things the students have made. So thank you very much, and be happy to answer any questions. Yes.
Do you know, is this something of a trend? Is this something other STEM schools that are sort of?
You know what, have not seen a lot of this sort of like real integration of art with engineering. It turns out, and I've collaborated with a lot of programs, especially on the blacksmithing things that we've been doing for a while. And it almost seems like that if you go onto a campus, you might find blacksmithing either in the engineering or in the art, but it's not, they don't really seem to talk a lot. And I don't know I mean, we have one of our team members, some of our artist team members here, but I think they might agree that it seems somewhat siloed on campuses. So I don't know of any efforts quite like this in materials. I do know that there is an effort in a lot of materials programs to bring back this more hands-on thing, because we've lost a lot of that. I was surprised to find out, for instance, recently that Rapid City Central High School used to have a foundry, but they don't have those types of things anymore. And I think the students really connect with that. And so I have seen a resurgence in those kinds of things where students want to really get their hands on things related to manufacturing or processing materials. But I haven't seen a lot of this. I've seen a little bit, especially on the ceramic side, in terms of like service learning, because ceramics sometimes are very inexpensive materials. So communities that may not have a lot of resources can make different things out of ceramic materials, but I haven't seen this sort of art connection like this. There are definitely other materials programs that have these activities, both glass blowing and metalworking and things like that, but I haven't seen such sort of an integration like that we're trying to do. But so we're excited about what we'll learn. Oh, yes. Yes, in fact, some of the classes that, and I don't know if did I mess up our presentation? We lost it on the screen here. But no, some of those classes, actually, the 150 millimeter challenge that Kat talked about, we're kind of integrating something like that in our senior level mechanical metallurgy course this semester. So yeah, we're infusing it kind of all across the board in terms of our curriculum. Well, yes, and from our standpoint, we tend to see a lot of students that come on recruiting visits and things like that. We're starting to almost get, people have heard that we're doing some of these things. So yeah, we are starting to see some student interest there. What I'm really excited about are some of these new classes that actually we're going to develop on glass materials and ceramic materials. I think that's going to be really exciting too. So we're actually going to develop new courses based on some of these principles behind some of these things.
We're still in the pretty early stages of this. I mean, funding came in the middle of last term. So I was the instructor for 110 and on the grant. So it was a very easy opportunity to integrate a lot of that. We started integrating it into others, but this program will last 3 years. Just integrating that will be, phases at a time. So, and we're already into this spring, starting to integrate it into about 3 or 4 different classes. So in time, I guess, is the answer.
Yo, yes. Well, yes, and maybe I might refer some of what I missed to one of our team members in the back there, but I think we're, the idea is to really help us connect with the community. I think through and get them interested in STEM through art, so some of our discussions have been about hosting, sort of co-hosting things at their facility that might be outreach efforts to get students to come in and work with artistic materials. I don't know if I've missed any things that I should mention here. I've got some other team members here, but especially maybe the artists might have some thoughts here on the team. Well, one of the things related to that, I was telling you that we have this glass blowing lab that's under construction. It's in a building on campus we call the Foundry building. And the Foundry building, we do metal casting. There's a metalworking, blacksmithing lab in there. There's a welding lab. We're establishing this glass blowing lab. But one of our visions for this Foundry is for it to be a space that local artists could come in and work with the students. They may have a project that they're working on, but the students could benefit from helping them on a project that's more artistic, where they learn some of these scientific principles, but also get to be involved with someone that's very creative and working on some projects. So that's kind of another aspect of something we're thinking along those lines of working with the Arts Council and working with local artists. Maybe that could be a user space in the future for artists to come in and work with our students. So yeah, good question. Any other questions? Well, all right. Well, thank you so much. And again, want to thank all of our team members. A lot of them are here. Thank you so much for helping us get this effort off the ground. And again, welcome you all to hang out and check out some of the things that students have made. And we'll, I think, wander around here. If you have any other questions, just let us know. Thank you so much.
I just wanted to also say thank you for coming in person and online. We had good attendance on Zoom again. We do this every third Tuesday. So next month, the STEAM Cafe will be on March 15th. It'll feature Dr. Laura Kremel from our humanities department. She's going to be talking about how the Gothic tradition plays a part in the health humanities, especially relating to the role that fear plays in pandemics and health policy. So it should be pretty interesting. Hope to see you on March 15th. Thank you for coming.